So in this section we are going to learn about turbocharger. Everything you are going to learn about turbocharger here. First of all, we'd like to thank our faculty from this institute who has provided me this material and upon request. So we'd like to thank him for providing the material. And so here we'll see the construction of turbocharger, types of turbocharger, all the terminologies and all the expected questions that can be asked from the topic turbocharger we are going to see. So first of all, before going to turbocharger, we are going to see first what is a supercharger. See, whenever we talk about supercharging, turbocharging basically comes under supercharging itself. So this term indicates that the weight of air supplied to the engine has been considerably increased. This allows more fuel to be used per stroke with the consequent increase in engine output power. More power is developed by a supercharged engine than by a non-supercharged engine of the same bore, stroke and speed. Okay, supercharging has had the effect of lowering the specific weight of diesel engines, that is, more horsepower is obtained per ton of engine weight. The term supercharging is now used generally instead of supercharging, where use is made of an exhaust gas turbo driven compressor. The term turbocharger is often used. Now you see here, here you have turbocharger and okay, only turbocharger. We have two turbocharger in series, that also we are going to see and discuss in detail. Under piston in series, under piston in parallel. Now, supercharging, pressure charging. The pressurized air needed to scavenge the cylinder of the, if you don't know, then we have already covered the topic scavenging, wherein we have covered the uniflow, loop flow and cross flow scavenging. Scavenge the cylinder of an exhaust gas and the supply the charge of the next combustion cycle was provided by mechanically driven compressors, that is root blowers, or by using the space under the piston as a reciprocating compressor, under piston scavenging. This of course meant that the engine was supplying the work to compress the air, which means that the useful work obtained from the engine was decreased by this amount. Okay, now when we talk about the advantages of pressure charging, it can be summed up here. The substantial increase in power for a given speed and size for the same size of engine. For a supercharged engine, we have much more power as compared to a engines which are not supercharged. Better mass power ratio, that is reduced engine mass for given output. Improved mechanical efficiency with reduction in specific fuel consumption. SFOC decreases. Reduction in cost per unit of power developed. An increase in air supply has a considerable cooling effect, leading to less exacting working condition and improved reliability. Now we come to the turbocharging. Now, by turbocharging an engine, the following advantages are obtained. Increased power of an engine of the same size, or reduction in size for an engine with the same power output. Okay, now you see a turbocharger basically consists of two elements. One is the compressor, the other one is the turbine. Now turbine side is actually which has suction for the hot air, the exhaust gases. Now the exhaust gases enters this turbine side and from here, and then it exits from here. Now this exhaust gas, because which is in motion with a very high temperature, now it rotates the turbine blade. Now when the turbine blade rotates, now the turbine blade which is associated with the shaft, okay, we are going to see all these things in detail. Now this shaft rotate, now this shaft drives the compressor. Now compressor blade drives and it creates a vacuum. Now when it creates a vacuum, then what happens? Then it sucks in the air. Okay, when it sucks in the air, then you have this air is basically supplied to the what you call is known as the to the engine. Okay, so this is what we had seen here. Now whenever we talk about turbocharging, there are two things what happens in a turbocharger. This can also be a question which can be asked sometime, that what is happening basically. So in turbocharger you find the kinetic energy get converted into pressure energy. So this can also be a direct question. Some things I've tried to note down everything, but few things I'm going to speak only, so you must be listening to it very carefully. Air is drawn axially. Now you see here, air is drawn axially into the center of the impeller with radial blades and is pushed radially by means of a centrifugal force. The rotation of impeller accelerates the speed of air and force rotation of impeller the speed of air and the force it to pass through diffusers and volute. Okay, diffusers and volute. Here high kinetic energy is converted to pressure energy, slowing down the speed of air through expansion. Now it slowly, you see the everywhere the curvature it getting expanded. From here it increases here. Expansion. Velocity energy is converted to pressure according to Bernoulli's principle. I have already covered a video on Bernoulli's principle and Archimedes principle and all these principles. If you have not watched, please do watch. So where pressure is inversely proportional to the velocity square. Okay, so these things have been here. Now you see here, so we'll go through this text. Increased power of an engine of the same size or reduction in the power of engine with the same power output. Reduced specific fuel oil consumption. Mechanical, thermal and scavenge efficiencies are improved due to less cylinder, greater air supply and use of exhaust gases. Now you see here, thermal loading is reduced due to shorter, more efficient burning period for the fuel, leading to less exacting cylinder condition. The turbocharger uses some of waste heat energy, about 7% of the total energy or 20% of the waste heat to drive a single wheel turbine. Now it's a single wheel turbine, it is being driven by it. Now when we talk about when we talk about this classification of turbocharger, then in classification we have a few things that we are supposed to remember, and that is what is known as in general the manner in which the energy of the content with the exhaust gases to drive the turbocharging two-way. Now there are pulse system, constant pressure system. Now these two are broad category: pulse type turbocharger and constant pressure turbocharger. You must have seen in generator engine and you must have seen in two-stroke engine. They are different based on types of turbine. Axial flow. Now based on types of turbine we have axial flow, radial flow. Based on bearing support we have sleeve bearing, we have roller bearing. Now based on arrangement of turbocharger we have parallel turbocharging, we have series turbocharging. In first slide I have shown you the parallel and series. Base turbine casing cooling, that is cool turbine casing, uncooled turbine casing. Okay, based on these things also we have this as the picture. Now you see here inlet, you have constant pressure supply, we have exhaust manifold, constant pressure, it is going here, we have this, and it is going to a common manifold. Okay, now we have inlet manifold, we have exhaust to the turbine, and we have compressor. Okay, inlet. Okay, now this is giving to the engine. Okay, so this is the classification, this is a cross section view of the turbocharger. Now we move on, we see pulse versus constant pressure turbocharging. So what is the difference between pulse and constant pressure turbocharger? When we talk about in pulse system, the high kinetic energy of exhaust is used. In high kinetic energy, I have already shown you that here what type of energy is converted into what type of energy. Basically it is the kinetic energy which is getting converted into pressure energy. Okay, now when we talk about these things, then we have one more system requires short unobstructed flow path. So here we need to have system which is short and unobstructed flow path. Okay, which is unobstructed flow path, and then we have reasonable low load efficiency and good response to change in the load, usually restricted to group of 3-cylinder exhausting to each turbocharger. So this is all about pulse type turbocharger. We have constant pressure, utilizes large volume receiver to convert kinetic energy to constant pressure energy. high heat energy supply to the turbine. Due to constant velocity, gas flow over the turbine blades provides more efficient turbine operation, but have poor response to load changes and low load operations. Hence requires a motor driven auxiliary blower as booster to low loads. There is no restriction on the number of cylinders that can be connected to the manifold, a greater flexibility in case of location of turbocharger and exhaust arrangement. Eliminates the excitation of turbine blade vibration by exhaust gas pulses. So here you can see the graph. Here you have turbine efficiency, and on another axis we have approx engine power. Okay, you can see the axial flow turbocharger and we have the radial flow turbocharger. Now here you have now here you have constant pressure operation, and you have this the pulse operation. Okay, now roller bearing and bearing versus sleeve bearing turbocharger. Now these two are very important, and often this is encountered in exams that they are asking these things. By surveyor they may be asking you these things. Now when we talk about these two aspects here, ball and roller bearing was integral lube oil supply system. Okay, uses integral lube oil supply system for lubrication. Self-contained self-contained gear type pump rotated by the shaft of the turbocharger provides both on blower and turbine side. Okay, air independent sump is provided, and sorry, an independent sump is provided on both side of turbocharger, and pump draws oil from the sump. So you must have seen a glass side glass. So we have from the sump which is giving going, and this getting it done for the ball and roller bearing. Side glass is provided for minimum and maximum oil level marking. Okay, outboard bearing is lubricated by main engine lube oil system through independent pump. Either it can be from main engine lube oil pump or through an independent system. Lubricate till 15 degree and for instant 22.5 degree centigrade. 6 meter head of tank pressure is greater than 1.6 bar. Supply time for 10 minutes. For 10 minutes we are using this and supplying this. Let's get on to the text aspect over here. You have seen the cross section diagram here. Advantages of outboard mounted bearing. Easy access, suited to ball roller type. So outboard bearing is ball roller type bearing. Avoid overhung mass. Better dynamic support for large unit. Okay, material, we have a gas casing, cast iron, maybe water cooled, nozzle ring and blade, chromium nickel alloy or pneumonic alloy. Pneumonic 90, nickel 75%, cobalt 18%, tin is 30%, aluminum is 2%, chromium is 2%. Compressor casing, aluminum alloy, compressor wheel, aluminum alloy, titanium or stainless steel. These can also be asked. Advantages when we talk about inboard mounted sleeve bearing, that bearings, shorter machine, rotor possible, better air inlet flow, high compressor efficiency. Disadvantages are less accessibility, high operating temperature, high friction at low loads. So we have high friction temperature at low loads. So these are the different advantages and disadvantages for inboard and outboard bearing. Now when we talk about the comparison between ball and sleeve type bearing, so one is the ball type, okay, and the other one is a sleeve type. So when we talk about the ball type, then it is the outboard mounted bearing, and whenever we talk about the sleeve bearing, then that is the inboard bearing. Okay, lower friction losses, roller contact, higher grade of lubrication requirement, roller bearing, more frequent bearing renewal, roller bearing, higher operating temperature of turbocharger possible, uncooled turbocharger, sleeve bearing, subject to Brenneling resilient mounting, that is roller contact. Now minimal lubrication, roller contact, high friction at low load, sleeve bearing, greater alignment accuracy, rolling contact, higher cost, roller bearing. Okay, now you see here you have the diagram, that tank we were talking about. Here, see here, this is the drain tank. Now from the drain tank the pump is taking suction, and this is through the filter. Okay, there are few systems wherein we have filter after the pump. Okay, so this is one of them. We have filter, and after the filter through the cooler, it is going and supplying to the supply tank. Now from here you supply tank, you see. Now this supply tank, it is by the means of gravity, it is going bearing oil supply to the turbocharger, to the both turbine and yes. And now from here also their drain also is going back to the drain tank, so it's a closed loop system. Now here the side glass that you are seeing, now there are two mechanisms here. You side glass, you see, one thing is that one more line from the supply tank is connected to the drain tank. The reason being is that whenever there is a overflow, this is the vent that is provided on both the tank. Whenever there is a overflow, then again it will go to the, that is this overflow line, it is going to the drain tank. From here you can see, yes, the supply tank is overflowed. Now here in the line we have an alarm. Okay, this alarm is provided, and we have an orifice plate. Now from this side glass, which is very important, we have already discussed the function and everything. Now here you can see leaf springs are where it is provided. I have shown you the cross section. We are going to see the function. Now the side glass that you are seeing, you must be going on round and seeing. Now that is what you are seeing, and here what is inside. Bearing cover, lubricating oil pump. It is here. It is mounted. Okay, here is the leaf spring, and is a ball roller bearing. Okay, ball roller bearing housing. This is the bearing housing. These are the bearings that you are seeing. Okay, it is just beside is the leaf springs. Okay, lubricating oil pump, bearing cover. Now here bearing cover, we have one terminology that is known as aspect ratio, that is AR. Now this can also be an independent question about the AR, aspect ratio. Indicates turbocharger, it indicates turbocharger housing size, how much housing size it is indicating. Now what this AR is, so for A you remember the area, from R you remember the radius. So AR, that is aspect ratio, can be that area of exhaust turbine inlet to the radius from turbine impeller center. Now air affects turbocharger lag. Now what air is affecting is a very important thing, aspect ratio. AR is affecting turbocharger lag and maximum airflow. Okay, maximum airflow. When AR increases, spool time will also increase. When AR decreases, spool time is also decreasing. Now this is your homework. Please do comment if you want what is spool time and all those things. I can cover it separately. It will go very long here. Now, what are parts of turbocharger? Whenever we are talking about parts of a turbocharger, then we come across a thing which is known as, see, three things: turbine, compressor, those blades of turbine, okay, blades of compressor, and then we have this shaft, the horizontal rotor. This may again be thought of two parts: the gas side shaft, which is turbine side, and the air compressor side. They are usually made of two material, as the condition that the wheel operates in is very different, has been constructed in parts and made hollow out of high alloy nickel chromium steel. The shaft carries a single stage axial gas turbine wheel at one end and radial single stage compressor at the other end. The shaft rests on slide sleeve bearing or end roller bearings. At the compressor end, there is a thrust bearing for keeping the rotor assembly in its true axial alignment, while it is free to expand at the other end. The rotor shaft is provided with a shrunk or the push for bearing and shrunk on labyrinth seal. The labyrinth seal are built into that parts of the bushing which is screwed with the casing. The rotor for a smaller blower may be a single piece forging, but for a large blower it may consist of two separate sections of shaft and turbine wheel with bolted connection. Okay, now you see here, in parts of turbocharger, all those things. Now you see here, this is locking strip. You see here, this is the locking strip here in the diagram. Now the fir tree arrangement, it is by the fir tree arrangement, blading side entry fir tree route. It is in blading side entry to the fir tree route. This is the pulse, this is the constant pressure. Okay, this is the difference between the geometry of the pulse type and the constant pressure type. Now we'll study the function of each type. Okay, now you see here the nozzle rings. Okay, here is the exact gas is converted into kinetic energy. Okay, creep resistant chromium nickel alloy, heat resisting molychrome nickel steel, or mnemonic alloy which will withstand the high temperature and be resistant to corrosion. Turbine blades are usually a nickel chrome alloy or a mnemonic material. Okay, a nickel alloy containing chrome, titanium, aluminum, molybdenum and tungsten, which has good resistance to creep, fatigue and corrosion. Manufactured using the investment casting process. Blade roots are of fir tree shape, okay, which give positive fixing. It can be asked why it is fir tree shape and where you find this fir tree shape. So please do remember, blade roots are of fir tree shape which give positive fixing and minimum stress concentration at the conjunction of root and blade. The root is usually a slack fit to allow for differential expansion of the rotor and blade and to assist damping vibration. On small turbochargers and the latest design of modern turbocharger, the blades are a tight fit in the wheel. We have lacing wires. This is the locking wire or the lacing wire that you are talking about is used to dampen the vibration, which can be a problem. The wire passes through the holes in the blade and damps the vibration due to friction between the wire and the blade. It is not fixed to each individual blade. The wire can pass through all the blades, crimp between individual blades to keep it located, or it can be fitted in shorter sections fixed at one end, joining groups of about 6 blade. It is fixed at one end. 6 blade together are combined with this lacing wire or locking wire. It is crimped both the side. For tree arrangement, you have understood. This is the lacing wire that you can see. Okay, now we see here intake system consisting of an intake silencer, intake guides, vanes or inducers. The function of the system is to admit air to the hub of the impeller without shock and friction. Air is given a centrifugal force so that it leaves the impeller vane at a high velocity. The displacement of air creates a suction inducting more air through the inducer. For larger engines, air filters on the blower have removal element. The filtering medium with the element may be plastic, fiber or a non-rusting material, wool material. That earlier one what we saw was for the turbine side, all these arrangement. Now here what you see is the compressor side. Okay, for large engine the air filter blowers have removable elements. We have already, the impeller of the centrifugal compressor is made by forging of light alloy, that is aluminum and silicon. The material, you should remember it. The physical properties of such a material are lightness, strength together with toughness and its capacity for a smooth surface finish. Now the diffuser is the name given to the fixed guide vanes surrounding the impeller. The high velocity of air leaving the impeller tip enters the fixed diverging vane of the diffuser. The air stream is slowed down in the diffusion process where some of the kinetic energy is converted to a pressure head. When we talk about these parts of turbocharger, the blower side, this is the whole diagram of a turbocharger. You see the blower side is equipped with a silencer. Here you have silencer. The air side casing is also in two parts but is made up of aluminum alloy. The inlet casing may be arranged to draw air from the engine room via filter and silencer arrangement. Okay, now you see here a grid is provided before the inlet to the arrest any large piece of metal or instant broken piston rings ends from entering the turbine and causing damage to the blades. The turbine casing is of cast iron. Some casing are water cooled, which complicates the casting. Water cooled casings are necessary for turbochargers with ball and roller bearing with, you remember, inboard and outboard bearing we have already discussed, with their own integral lube oil supply. So here we have own integral lube oil supply to keep the lube oil cool. Modern turbocharger with externally lubricated journal bearings have uncooled casing. They have uncooled casing. So we have even turbochargers which are uncooled. This leads to greater overall efficiency as less heat energy is rejected to cooling water and is available for exhaust gas boiler. The turbine is mounted because a part of energy you are using in the turbocharger, so lesser heat energy is available for the boiler, exhaust gas boiler, EGB. The turbine is mounted in a case iron casting two-part casing which comprise of gas inlet housing, the nozzle rings and a gas outlet casing which forms the main part of the frame. Traditionally the casing has been water cooled, but the latest type has moved away from these designs in an effort to increase efficiency. Turbocharger sealing arrangement. So when we talk about the sealing arrangement, we have labyrinth seals. Okay, these labyrinth seals are also found in some other places. You may comment there. This, you have exhaust gas, you have casing, you have sealing air. They are provided at each end of the rotor and between the turbine and compressor, and serve to prevent the passage of exhaust gas and also to prevent oil, lead and air being drawn into the eye of the impeller from the bearing. Oil seals in the form of thrower plates are also fitted at the bearing to prevent the passage of oil along the shaft. Labyrinth seal consists of projections on the rotor which almost touching the casing. So it is almost touching the casing. Air blade. Air is bled from the compressor head into the middle of the turbine gland. This air expands in both directions and provide a very effective seal. The flow of air in the center gland also aid cooling and minimizes the heat transmission from the turbine wheel. Principles of labyrinth gland. The leakage of exhaust is reduced by the use of labyrinths. These provides a tortuous path for the gas to follow to exit the turbine, reducing the pressure across a series of fine clearances. Okay, now we have seen the diagram wherein we have seen the series turbocharging. Now, what are the advantages of series turbocharging? See, these are already condensed note. There is no need to explain anything because the video gets longer. The advantages: series turbocharging with two-stage compression with intercooler R. Stage turbocharging gives higher air pressure and mass. Both charge air coolers can be fresh water cooled, and if a central cooling system with temperature control is utilized. So you see here, same way we have in air compressor, same way we have after cooler, HP stage and LP stage, exhaust waste gas. You see here the diagram. Total energy saving may be made. Waste gate. Now what is this exhaust waste gate? In order to improve the part load air supply and the engine performance, the nozzle area can be reduced at the design stage. However, this option will produce excessive pressure at full load. In order to reduce the scavenge pressure, the excess pressure will have to be dumped. Although this option has a slight fuel penalty, plus 2% fuel loss we have. Air bypass valve. In order to achieve better engine to turbocharger matching and a wider load profile, bypassing of engine by the charge air can be carried out. This dumped just after the compressor to the exhaust gas line. This will increase the airflow to the compressor, hence reducing the possibility of surging. Now this is a Miller cycle. The Miller cycle is an operating cycle for internal combustion engine which is essentially characterized by following main features. So it has the following features, that is effective compression stroke shorter than the expansion stroke, high pressure supercharging, we have variable valve timing which is also achieved. Having two turbochargers in parallel. When we talk about parallel turbocharging, that was series turbocharging. Key, one's outlet is going to the other's inlet. Okay, here we have parallel turbocharging. With two turbocharging parallel provides the following advantage, that a single turbocharger fault on only turbocharger drastically reduces the engine output. Single large turbocharger will have higher inertia and thus longer to respond to load change. Cost of replacement of parts more expensive. Power take in turbine, PTI. When we talk about PTI, at full load there is more exhaust gas energy available than that required to supply scavenge air alone. The sum of the exhaust gas can be passed through a radial gas turbine, which can either be used to provide energy direct into the propeller shaft via greasing or into the electrical system. So you see here in the diagram, this is the PTI curve you have all together, and you see here that the arrangement, that is tooth coupling, crankshaft gearing, the tooth coupling, and then we have the flexible coupling, hydraulic coupling, and these are bevel gear. You must have studied about the bevel gear. This is the crankshaft. Now VGT, that is variable geometry. When we talk about this variable geometry altogether, this has a reduction in SFOC. Whenever we talk about variable geometry, it has a reduction in SFOC, specific fuel oil consumption. Okay, now when we talk about the elimination of dependency on ambient conditions, so it also eliminates dependency on ambient condition altogether. Now we also have what is known as stopping blowers at lower load earlier stage, higher flexibility and improved dynamic response. So dynamic response also gets improved. Okay, now variable guide vanes, these are basically in vanes shape. Okay, turbine casing, all these things you see here with the parts are being described here with the name. Okay, VGT has nothing but it has vanes. It adjusts, it basically basic function, it vanes adjust to match the RPM. Okay, so at different, because turbocharging was basically for a constant speed. Turbocharger works efficiently when you have a fluctuating load, doesn't do it. So for improving that design, what has come into picture is known, what is known as vanes. Okay, now let's go and see turbocharger generator mode. We have advanced in high speed generator technology as well as high capacity electronic switching have fostered the parallel compact high output generators and frequency converters suitable for use with turbocharger. We have hybrid turbocharger in which high speed generator is attached directly to the turbocharger rotor shaft. This arrangement has following advantage: elimination of piping and valves associated with feeding exhaust gas to power turbine, control of turbocharger performance by raising and lowering generator output, use the generator as a motor as a substitute for the auxiliary blower of two-stroke engine. Motor mode can also be applied to accelerate the turbocharger rotor and improve the turbocharger performance, particularly at low load range of the engine. Higher efficiency due to energy conversion by the turbocharger turbine. We have this cable terminal box, the silencer you see, generator housing, generator coil, generator rotor, generator support, and then we have this what is known as diaphragm coupling. So this was turbocharger generator mode. This is the latest that has come up. Now when we talk about turbocharger surging, okay, this is another phenomena that is occurring, what is known as turbocharger surging. Okay, whenever we talk about this turbocharger surging thing, if the mass flow rate of the given pressure ratio drops, then the delivery becomes unstable and surging occurs. At a certain point, the pressure built up in the air manifold blows back through the compressor, causing the surge in the turbocharger revolution, the noise level and vibration. The system will now stabilize itself, pressure will be built up again, and if the condition causing the surge is still present, the cycle will repeat itself. Depending on the degree of restriction, the frequency can be anything from a few seconds to a number of minutes. To minimize the possibility of surging occurring, reduce the engine speed. Proper matching of the turbocharger to the engine is very important. That is, the engine operating line should be far enough to the right side of the surge line. Clean air inlet, filter, air cooler and scavenge ports to provide unrestricted, okay, to provide unrestricted passage for scavenge air. Clean fouled exhaust grids, nozzle, rings and exhaust gas economizers. Okay, economizer prevent back pressure and exhaust. A balanced engine altogether. So here we have seen in the diagram, you see here how it is there, how and why this phenomenon of surging is occurring. Now we go on to the matching of turbocharger. So this is not so much important an aspect, so if you want you can just have a look. I will just move on. So surging was basically nothing when there is a breakdown of airflow. So in a nutshell I will say, meanwhile if you want you can go on through this. Surging is nothing but when there is a breakdown of airflow takes place in turbocharger, a reversal of scavenging air occurs through diffuser and impeller blades into the blower side, which causes surging. So this is the reason for surging what we have. Okay, now we go turbocharger cleaning. So if see why we are doing this cleaning thing is all together. See, this is activated charcoal and this is walnut shell. This you must have often seen, and there is water washing as well. We have wet cleaning and we have dry cleaning. Now, if turbine side cleaning is not carried out, then fouling may lead to back pressure and surging, resulting in breakage of turbine blades. Okay, so see the importance of this cleaning. If blower side cleaning is not carried out properly, then supply of air to the engine will be reduced. Okay, so that is the reason why we are doing this cleaning. Now, when we are talking about what is known as turbine side, we have two things, that is water washing as well as we have dry washing altogether. But it is advisable that turbine must be dry cleaned after every 20 to 50 hours of operation. Turbocharger dry cleaning can be without or with very little reduction of engine load. Okay, at full load we are doing this turbocharger cleaning and dry cleaning. Turbine wet cleaning carried out every week. Engine load has to be reduced less than half and continued for half hour before returning the load to normal. Before returning the load to normal, we are doing this cleaning. So here you see, this here only you are inserting this walnut shell you must have done. Okay, cleaning of impeller and volute casing is done at every 25 to 75 hours of operation. A fixed quantity of water is injected at the eye of the impeller over a short period of time to remove deposits from the surface. There is no need for reduction of speed during the procedure. So this is the arrangement for water washing, and this is the arrangement for dry cleaning. Okay. So when we talk about water washing, engine speed is reduced to make exhaust temperature to around 420 degrees centigrade. Fresh water used must be slightly hot. Water injected through a regulating valve connected through it, through turbine side. So there is a regulating valve which is connected. You can see in the diagram. To avoid thermal shock to machinery. Okay, drain kept open. Now this is the drain, you see here, this is the drain which is always kept open. There only you have a regulating valve, water supply valve, water pressure gauge you have. Okay, now when water feed is closed, drain is observed until water stops coming out. Engine run for further 20 minutes at slow RPM to dry out the turbine from water. Before increasing RPM, drain is shut and any abnormal vibration must be observed. Now when we talk about dry washing, for dry washing carbon granules are injected inside. This is all about turbine through compressed air. Now you see here dry granules are injected from here. This is the compressed air line which is going there. Okay, now this is the granule box. The engine speed is not reduced as there is no risk of thermal stresses in dry washing. In dry washing there is no risk of thermal stresses or imbalance which is there in case of the wet washing. Blower side cleaned by fresh water. Now blower side is only cleaned by fresh water only. Engine is run at full load RPM. A container is filled with an inlet line coming from the blower discharge side and outlet line from the container or cylinder gear to goes to washing blower side. So this is all together by turbocharger cleaning. So we have discussed here a lot of important things. What is turbocharging, supercharging, different types of turbocharger, what is the advantage of turbocharging. Okay, what is the construction of turbocharging lubrication, inbound, outbound lubrication, material of turbocharger casing. We have discussed aspect ratio. We have discussed surging of turbocharger, what are the reasons of surging of turbocharger, and everything in detail. What is turbocharger washing? The turbine side we are doing water washing, what is the process. Dry washing also, what is the process. Blower side we are doing it with fresh water only, that is wet washing, and how we are doing it. Thank you so much, thank you for your valuable time. The video was little longer, but I wanted that everything should contain in one video. All the best.